Now this question is again finding the magnetic induction at the center, but this time we have a sphere, not circle. Due to the circle, everybody knows the magnetic field, magnetic induction is mu naught I by 2r. This time we have a sphere, so let us say I have a sphere here. So this is a sphere that is given to you, and this sphere has a radius r. So the radius of a sphere is capital R, and this carries current, not current this time, this carries surface charge density. So this is charged with surface charge density sigma. So this sphere is charged with surface charge density sigma. So now I can say what is sigma. So sigma is surface charge density. So this is surface charge density. Now we have to calculate magnetic induction at the center. Now this question says this sphere is basically rotated. So this sphere gets rotated about an axis. So let us say this is the axis of rotation. So this gets rotated with angular velocity omega. So we have to find magnetic induction at the center, magnetic field at the center. How will proceed? Now what we will use this time, we will use this result. That is, if you have a circle and you have a point some distance away from the center. So let us say here you have some point at a distance x from the center. So this distance is x from the center. We can write magnetic field at this point. This carries current I. So this loop carries current I. So magnetic field is given by, if you remember this, it is given by mu naught I a square divided by 2 under root a square x square plus a square raised to the power 3 by 2. Are you getting or not? And we also said this is a. So radius of loop is a. Are you getting or not? So this is the formula we have. So we will use this formula. How will we proceed? So to proceed this one, what we will do is, so let us say, let me make again this sphere. So this is my sphere. So this time making slightly bigger. And now this is my axis of rotation. And this is rotated with angular velocity omega. So let us say I have a elemental ring from the center. It makes an angle theta. So let us say at angle theta I have elemental ring. I can make something a better way. So this angle is basically given to you. This is angle is theta. Now I can calculate what is this length. Can you calculate this length? If this length is r, then this length has to be r sin theta, and this length is r cos theta. Are you getting or not? So this length is nothing but r cos theta. So this length is r cos theta. Are you getting? So this is r cos theta. Slightly difficult. Are you getting? And now this length, you know, basically this length is r sin theta. So this length from here, from the center, you will have this length. This is r sin theta. Are you getting or not? So this is r sin theta. Now if you consider again another ring, another elemental ring of radius, this is an angle theta. Next ring, if I consider that angle of theta plus d theta, so something like this side. Are you getting or not? If I consider another ring, so this ring is my, let me make the same thing again. So I have a ring, and this is my axis of rotation. This is my axis of rotation, and this ring makes an angle theta with the vertical. So this angle is given to you theta. Now let us say if I consider another ring at theta plus d theta, So I will have something of this kind of ring. Are you getting? Slightly difficult to understand. So I will have another ring at theta plus d theta. Are you getting? So this is at theta plus d theta. So basically you can calculate what is the area of this ring. You can calculate. Are you getting or not? So what is the area? So thickness is r into d theta. If this is capital R, and if you move in this side with angle theta, d theta, so if you move here with angle d theta, then this becomes the thickness. So thickness is r d theta. So thickness I know this is r d theta. What is circumference? That is 2 pi r. But r is what? R sine theta. So what is area of elemental ring? So now I can say area of elemental ring is equals to, so now I can write here area of elemental ring. So I will have area of elemental ring. So this will be equals to, so area of elemental ring is equals to 2 pi r, but in place of r you will have r sine theta, 2 pi r into r d theta, that is 2 pi r dr. So this is the elemental ring. What is the charge over this elemental ring? So let us calculate charge over this elemental ring. So charge over elemental ring. So this is easy. Charge over elemental ring, and this time charge we will have simply this multiplied by sigma. So this is equals to dA times sigma, and dA I have already calculated, that is 2 pi r sine theta. So this becomes r square sine theta d theta, sine theta d theta into sigma. So this is your elemental charge. What is the current due to this wire? So current due to this elemental ring. So current in the elemental ring. So next is current in the elemental ring. This is easy. So I can calculate current, that is nothing but Q by time, and Q is what? This is the Q, and time is 2 pi by omega. So we will have 2 pi r square, and let us put sigma here itself, sine theta d theta, this divided by time, and time I already know, that is 2 pi by omega. So this becomes 2 pi goes, so I will have omega r square sigma sine theta d theta. Are you getting or not? So this is sine theta d theta. So this is the total current in elemental ring. So due to this elemental ring, what is the magnetic induction at center? So due to elemental ring, magnetic induction, due to elemental ring, I can go fast slightly. Due to elemental ring, B, or let us call dB, a small dB. What is the dB? So this can be given, and now this is a situation of, so you have elemental ring here, this is a circular part, and you have a distance r cos theta, this distance. So what is my radius? Radius is, now I can use this formula and then put this everything. So I have this formula. In this case, A is the radius of ring, so A is r sine theta. So for my question, I will have A is equals to r sine theta, and x will be basically r cos theta. Are you getting or not? If I plug these values, I can get, this is mu naught Ia square, mu naught Ia square. So this is mu naught Ia square divided by 2 A square plus x square raised to the power 3 by 2. You check again. This is mu naught Ia square 2A square plus x square raised to the power 3 by 2. Are you getting? Now I have to plug all these values. So this is a small magnetic moment, a small magnetic field dB. This is mu naught. What is the value of I? We have already calculated, that is omega r square. But now what is my r? This r is constant. sine theta d theta. This is I, and then a square. What is a? R square sine square theta. So r square sine square theta. So it's a big term. And this divided by 2 a square plus x square raised to the power 3 by 2. And this is easy. You see, what is a square plus x square? A square is r square sine square theta, x square is r square cos square theta. So this simply becomes r square raised to the power 3 by 2. So this becomes r square raised to the power 3 by 2. So this becomes r cube. Are you getting or not? So we will have, so mu naught omega sigma, let us take this constant one side, mu naught omega sigma, and r square r4, but then in the denominator we will have r cube, so we will have simply r, and this divided by 2, and then we will have sine q theta d theta. Let us check again. I have to integrate this thing only, so to get the total b. So if I integrate both sides, what will the limit? So this is 0 to b, and here I have to integrate 0 to pi. Are you getting or not? Try to understand. You see what we are doing? We are doing, so if you take 0, I will be having somewhere here. This is my circle. If I have pi by 2, I will having a circle here. If I have pi, I will have this point. Are you getting or not? So this is my, so I have to integrate this one 0 to pi. Now this is your task. You can do your integration yourself. How will you proceed for this integration? If you remember sine 3 theta, if you remember the formula for sine 3 theta, you can do yourself. Sine 3 theta is equals to, I think, 4 sine q theta, 4 sine q theta minus 3 sine theta. As I remember, let me check this is right or wrong. If I take theta is equals to 90 degree, I will have theta equals to 90 degree. This means 4 and this is 3. So this is theta equals to 90 degree. I will have this side 1. What about this side? This side I will have minus 1 because 270 degree. So I have written basically wrong. So I have to have this minus here and this plus here. So now I can calculate sine theta, sine q theta from here. So I will have 4 sine q theta. This is equals to 3 sine theta minus sine 3 theta. So I need sine q theta. So sine q theta is, this is simply 3 sine theta minus sine 3 theta by 4. So this divided by 4. Now if you integrate this as 0 to pi, so let us say if you do integration this, so 0 to pi, this is 3 sine theta, so 3 by 4 sine theta d theta minus 0 to pi 1 by 4 sine 3 theta d theta. So this is my integration. So sine theta, integration of sine theta, we will have cos theta, I think minus cos theta, this is 0 to pi, and this is 1 by 4 sine 3 theta is cos minus cos theta, so minus cos 3 theta divided by 3, and this is again 0 to pi. So if you do this integration, what we will have? So cos pi is, so let us take minus sign outside, so we will have minus 3 by 4, cos pi is minus 1 and cos 0 is 1, so this is 1 minus 1, so minus 1 by 4. Let us take minus sign outside, so we will have plus here. Cos 3 pi, so we will have 3 also multiplied, so this is 1 by 12, it will be having 1 by 12. So let me write here 1 by 12. So this is 1 by 12. Cos 3 pi, that is a pi, cos 2 pi plus pi, that is simply minus 1. And then cos 0 is again minus 1. Are you getting or not? So cos 0 is minus 1. So what is this value? So slightly difficult. So let me check. So this is 2. So this is minus minus plus. So this is 3 by 2. And what about this? So this is minus. This is 2. So this is 1 by 6. So this is minus 1 by 6. Now if I take LCM 6. So 2 into 3. So 9 minus 1. So this is 8 by 6. So that's a difficult integration. I have never thought. This becomes so interesting. So this is 4 by 3. Now I have to plug this value of integration, that is 4 by 3 here, and everything is done. So this becomes, this integration is 4 by 3. So if I plug this integration here, so this will have 4 by 3. So this is 2 by 3. So you multiply this 4 by 3 and 2 goes. So you will have in 2 by 3. So this is 2 by 3 mu naught sigma omega r. Are you getting or not? Simply plug the value of this integration. This integration I have already calculated, that is 4 by 3. If I plug this value 4 by 3, this comes out to be 2 by 3 mu naught sigma omega r. So now I can write the total magnetic field at the center, that is 2/3 of mu naught sigma omega r. If you can remember these formulas, that will be nice. These days people remember these formulas. For me it's very difficult, I can't remember. But then how can I suggest you have to remember? Okay, let us discuss next.